With BricsCAD, you can create assemblies of parts with different densities. In this video, we'll show you how to design a self-balancing wine bottle holder by using assembly mass properties calculations and 3D constraints. Here in this model, we have assembled a full bottle of wine, complete with its cork. Each part of the wine bottle has been assigned its own density, as has the wooden bottle holder it's mounted in. From the specified density, the weight of each component can be calculated from its volume. This information can be included when generating a bill of materials. Alternatively, we can simply use mass properties to output information on our selection to the text screen. You are even given the option to align your UCS with the equilibrium point. Here you see the combined mass and volume of the selected objects, along with the center of mass and moments of inertia. To find the equilibrium point for the self-balancing wine holder, simply draw a line from the center of the holder to the center of mass of the assembly. This line represents the normal direction of force caused by gravity relative to the top of our table. To orientate our wine holder to its balance point, we simply have to apply a perpendicular constraint. Having applied the constraint, we can see that the bottle touches the surface of the table. To fix this, we can modify the position of the bottle in the holder and change the shape of the holder. Now the wine holder has been modified. We can recalculate its center of mass using mass properties. By applying the same perpendicular constraint, you can see that we have achieved an acceptable point of balance for our bottle holder. So, there you have it, a self-balancing wine bottle holder created with BricsCAD Platinum, using assembly mass properties calculations and 3D constraints.
BricsCAD, more than ever, is a real choice.